Hello students, welcome once again. See, that is the question for today. As you can read the question here, of course it's handwritten today, but okay, you would have got it as a post, as a proper post in the morning. See, that's the question which says if Z1, Z2, Z3 till Z100 are roots of this equation. Which equation are roots of this equation? Then we have to evaluate the value of this series. Okay, so what this series is, so if I just write it like so, the series is summation of 1 upon zk minus 1, where k goes from 1 to 100. So that's our series. So we have to evaluate this series. So where the information is that z1, z2, z3 are the roots of this equation. See, if you ask me, it's a question of specifically a question of complex number, my answer is no. Okay, this is a simple direct question of algebra according to me, though using alternate method you can turn it to a question of roots of unity from complex number. Okay, so I will discuss both of them. First I am going to discuss with what I started and how I solved it in the first instance. Then what else we can think on it. Okay, so I said, okay, since z1, z2, z3, z100 are roots of given equation, whatever that equation be, bachcho. Since we know the roots, don't we know the factor of its corresponding polynomial form? Like, by roots of which equation? Roots of 1 plus z square plus z is for 100 equal to 0. And we know that if we know the roots, we can write this polynomial as z minus z1 into z minus z2 into, so that's the application of very basic algebra that we know since our 9th class, isn't that? So we know roots, we know factors of the polynomial. We can express that polynomial in terms of the factor. Now look at this series. So which is what? Which is 1 upon, if I go on putting the values here, so z1 minus 1 plus 1 upon z2 minus 1 and so on and so on. That's the series, and this is the form which we got. Okay, so the idea which struck me was, why not take log? See, log is one function, I always say log is one function that converts product of terms to the sum of terms. Okay, and then see, if I differentiate ln t, what we get? 1 by t. Okay, so these are two things which I am going to mix here to reach the series here, or to get this series here. So what I said, okay, I said taking ln both the sides, taking log to the base e both the sides, what do we get? So I get here ln of 1 plus z square and so on till z is for 100, and in RHS of course ln of z minus z1 into z minus z2 into and so on till z minus z100. And we know from the property of log, and that is, what is it? That if I write ln of a into b into c, we can express it as ln a plus ln b plus ln c. Okay, so I can write it as ln of z minus z1 plus ln of z minus z2 and so on till ln of z minus z100. Okay, now see, as I said, why not to differentiate it? Because see, the moment you differentiate it, you get this type of terms in RHS. So let's do it. So differentiating with respect to x, so all respect to the complex number z here. So differentiating with respect to, not x of course, with respect to z here. So derivative of ln t in LHS, of course we will be differentiating both the sides. So derivative of ln t is 1 by t. So I will write it as 1 by t, which is the input of ln, which is 1 plus z square, this entire polynomial of degree 100, into using chain rule of differentiation. What we will write here? Okay, derivative of 1 is 0 plus derivative of z is 1, z square is 2z, z cube is 3z square, and so on. Z is for 100 is 100 into z is for 99. That's your LHS. Now let's come to RHS. So derivative of ln of t is 1 by t, so 1 by z minus z1. And then even if you apply it, I mean if you want to apply chain rule, then also you will get derivative of z is 1, so that's it. So see, that gives us the series itself, isn't that? That gives us the series itself. But if you can compare it with the given form, we don't need z minus z1 or z minus z2, we need 1 minus z1, 1 minus z2, though with negative sign. So what does that mean? That means we will be substituting. So now we will be substituting z by 1 both the sides. So just put z is equal to 1 in LHS first. So we get 1 plus 2 plus 3 and so on till 100. And how many times 1? 1 plus 1 plus 1 till z is power 100. So how many times is it? Bacho, 0 to 100. It's 101 times, isn't that? So it's 101 times. Now in RHS, what do we get in RHS? When I replace z by 1 here, so we get it as 1 upon 1 minus z1 plus 1 upon 1 minus z2 and so on till 1 upon 1 minus z100. Okay, so in numerator is sum of first 100 natural number, and the sum of first n natural number is n into n plus 1 by 2, n is 100, so 100 into 101 by 2, so 100 into n plus 1 by 2, and in denominator you have 101 terms, so it's 1 plus 1, 101 times is 101, and in RHS we have whatever we have actually. Okay, now I will take minus common from all denominators so as to get it in the form which we need, and that's the form in which we need our series. Okay, so that's it. So z is 100 minus 1, that's it. Okay, 100 gets cancelled. So the answer according to me for this series where k goes from 1 to 100 is minus 50 bachcho. Okay, so that's one method where I said I didn't use anything related to complex number. I just used very basic concept of algebra which relates the roots and the factors of the polynomial, and then I use log function to convert the series of product to the series of sum of terms and then differentiating both the sides. Okay, see, the other idea could be, the other idea can be here, since z1, z2, z100 are roots of which equation? 1 plus z. See, why am I discussing it? I'm not going to discuss it till the end. You all can think on it, and if you face any problem, then you can tell me with the help of comments. I will try to clarify that thing. But my point is, see, that's a GP of 101 terms whose common ratio is z, first term is 1. Okay, so I can write this as z raised to the power 101 minus 1 upon z minus 1 equal to 0. So z raised power 101 minus 1 equal to 0. So these are the roots of, so which root of unity? So this implies these are roots of 101th roots of unity except 1. Okay, only the one root of out of 101 roots. See, these are 100 roots of this equation. One root is 1, which was missing because 1 won't satisfy it, and the reason is that gives you 0 by 0 form. I mean, that's undefined type of thing here. Okay, so these you can look at it as the roots of unity also, 101 roots of unity also, and then if you wish you can use those things and try to solve it using the concept of complex number and roots of unity from here, bachcho.